2652. Okay. All right, let's go back to our light bulb problem. We select one from the box. This time we don't replace it. So the probability of a good light bulb changes. Probability of a good light bulb for the first good light bulb is still 80%. But the probability for the second good light bulb is not 80% anymore. I did not replace the bulb, so I'm no longer into these independent events. I'm into dependent events. I only got 4 bulbs left in the box, and only 3 of them are good. So the probability that my first bulb is good and my second bulb is good is, there are 4 out of 5 good ones in the box. Take one out, put it in the light socket. Now I got only 3 good bulbs out of 4 in the box. So this would be 12 out of 20, or 3/5. Or 0.6. Okay, so that's the difference between the conditional probabilities and the probabilities that you do for independent events. Yes?
So you sort of assume that you didn't take out a bad one?
So if I want to find out the probability of getting a good bulb and then another good bulb, then I assume that I got a good bulb on the first one. Okay. If I am, so, I kind of need to know what my conditions turn out to be. So I need to make some assumptions about the first bulb, whatever assumptions I can make. So if I didn't, if I just wanted to know the probability that the second bulb was good, and I don't know the condition of the first bulb, well, the probability the second bulb is good, there are, as far as I know, 4 good bulbs left in the box. And I'm sorry, as far as I know, there are four bulbs left in the box, but I don't know the conditions of the box. Yeah.
What did you say, conditional or independent?
So if your probabilities are going to change from getting the first selection to the second selection, those are going to be dependent events.
Okay.
Okay.
Conditional as well.
And so then we're doing this little conditional probability calculation, which is this calculation. Oops. This calculation is conditional probability because I already know I've got something's already happened. I no longer have a probability of 4/5 because something has gone on that I can measure. Okay, last one, a little trickier, not much. Probability of randomly selecting an all-male 10-member debate team from a group of 30 students, of whom 21 are male. All right, so you've got 30 students in a room, 21 are male, 9 are female. I'm going to randomly select them. What's the probability that as I pull these names out of a hat, as I pull these people into my group, that I never pick a female, that I just get the males? Okay. So to get the first male, what's the probability? And I'm going to go 21 out of 30, and I'm not going to simplify my fractions at all. Okay? So there's 21 males out of those 30 students. I have picked that name, and I have set that guy aside. What's the probability that the next one I'm going to pick is going to be male? 20 out of 29. And the third one is going to be 19. And there's only 28 left. And 18, and 17, and 16, and 15, and 1, 2, 3, 4, 5, 6, 7. Oops, 24. 14 out of 23, 13 out of 22, and 12 out of 21. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you just multiply those fractions. And it doesn't seem to overflow the calculator, so you're okay. Okay, so the hardest part is to figure out